What if Mars was never just a barren red desert? What if, long before Earth carried cities and stories, Mars was alive with oceans, air, and even civilizations that thrived under a red sky? Imagine standing on a planet where the signs of intelligence have been buried for millions of years, waiting for us to notice. If this idea is true, it could mean that human history is not the beginning of civilization, but just the latest chapter in a much older story. Stay with me until the end, because this theory changes how we see both Mars and ourselves. Before we dive in, make sure to subscribe to the channel. That way, you won't miss the deep explorations we do into strange, hidden possibilities that may reshape how we understand our place in the universe. Mars has always carried a strange weight in the human imagination. When you look up at the night sky, it appears as a small red dot, different from the cold white shine of other stars. That redness gives it a sense of being alive, a planet with character. Ancient civilizations noticed this difference thousands of years ago. Babylonian, Egyptian, and Greek observers all wrote about the wandering red light in the sky. They tied it to gods of war, conflict, and passion, because even at that time, Mars stood out as unusual. This history of watching and wondering about Mars is not new. For as long as we've tracked the planets, Mars has been a focus of speculation. The reason Mars fascinates people is simple. Unlike the gas giants, it looks like a real place. It is not too far away. It is not made of swirling storms. And it is not hidden by blinding brightness like Venus. Through telescopes, Mars reveals a surface. You can see patches of light and dark ice caps that grow and shrink with the seasons, and dust storms that sweep across its deserts. It looks more like Earth than most other planets we know. That similarity is enough to spark curiosity. If Earth has life and civilizations, then why not Mars? By the late 1800s, telescopes had advanced enough for astronomers to see details on Mars. An Italian astronomer, Giovanni Schiaparelli, looked at the planet and described lines he thought he saw on the surface. He called them canali, meaning channels or grooves. But in English, the word was mistranslated as canals, suggesting artificial construction. That one mistake sent the imagination of the world racing. American astronomer Percival Lowell took the idea further, writing that these canals were built by intelligent Martians to move water from the polar ice caps to drier regions of the planet. Newspapers, writers, and eventually the public all became interested in the possibility of life on Mars. This was the first time the idea of a Martian civilization entered popular thought, and it has never fully left. Even after modern science corrected the mistake, people kept wondering. Telescopes improved, and the lines Lowell had described turned out to be optical illusions, patterns created by the human eye. Yet by then, the seed of the idea had been planted. If civilizations could rise on Earth, it was not impossible to imagine that they might also rise somewhere else nearby. Mars was the natural candidate. For science fiction writers, Mars became a canvas. Stories of Martian invaders, ruined cities, or ancient technology hidden under the dust became a way to explore our own fears and hopes. H.G. Wells' War of the Worlds is the most famous example. But hundreds of books and radio shows carried the theme. The important thing to notice is that even in the absence of proof, the human mind was drawn to Mars as if it carried a memory. There is something about its landscape that suggests possibility. When spacecraft first flew by in the 1960s, they showed a barren, cratered world. Many people felt disappointment. But the curiosity did not end there. Instead, it evolved. If Mars is not alive now, maybe it was alive in the past. Maybe what we see today is not the full story, but the ruins of something much older. This is where the idea of lost civilizations comes in. Earth itself holds evidence of resets and forgotten pasts. Entire cultures have been buried under sand, water, and jungle. Great cities like Troy, Angkor, and Machu Picchu were lost for centuries until rediscovered. If such erasure is possible on Earth, a planet that is still alive with tectonic and biological activity, then how much easier would it be on Mars, where dust storms can bury landscapes and erosion is slow but persistent? The lack of life might mean that evidence survives, hidden just beneath the surface. Waiting to be uncovered, scientists have confirmed that Mars is not simply a dead rock. It has ice caps made of both carbon dioxide and water. Probes and rovers have revealed ancient riverbeds, valleys, and minerals that form only in liquid water. This means Mars once had conditions that could support oceans or lakes. If water was present for millions of years, then the environment could have been stable enough for life to emerge. Once you accept that, it becomes harder to dismiss the possibility of more complex forms of life. From there, the leap to intelligence, while speculative, is not beyond imagination. The reason theories of Martian civilizations hold power is not because we have found solid proof, but because Mars presents a chain of maybes that remain unanswered. Maybe the canals were just illusions, but maybe Mars really did have flowing rivers long ago. Maybe the structures we see are only natural formations, but maybe they resemble things we know too closely to be chance. Maybe Mars lost its atmosphere and became a desert, but maybe that change destroyed something more. People are drawn to fill in the gaps with stories, and the human mind naturally looks for patterns. When you look at images of the face on Mars in the Cydonia region, your brain sees a face. Even when later, higher-resolution images showed it was just a hill with shadows, the question remained in the public imagination. What if it was once real? This pull toward speculation is not just about fantasy. It comes from a deeper urge to understand if we are alone. If Mars once had civilizations, then humanity is not unique. We would be part of a longer chain of intelligent life in our solar system. That possibility has weight because it changes how we think about our future. It suggests that civilizations can rise and fall on planets other than Earth. And that intelligence might not be a rare accident, but a repeating event wherever conditions allow. Of course, mainstream science remains cautious. Most researchers accept that Mars was once more habitable than it is now, but few argue for past civilizations. The evidence we have so far is geological, not cultural. Rocks, minerals, dried river valleys. These are real, but they do not yet prove life, let alone intelligence. And yet, the gap between what we know and what we suspect is wide enough to keep curiosity alive. For the public, the dream of a Martian civilization is compelling because it gives meaning to the search. We are not only looking for microbes or chemical traces, we are looking for connection. 4 stories written in stone and dust. Every new mission to Mars, from orbiters to rovers, renews this curiosity. When NASA's rovers send back photos of strange rocks or unusual shapes, people study them closely, often with more intensity than scientists expect. Forums fill with claims of ruins, statues, or mechanical parts. Most of these turn out to be natural formations. But the fact that so many people want to see them as artifacts shows the strength of the idea. It's not just about science. It's about a deep-seated hope that we are part of a larger history. There is also another layer to why Mars attracts these theories. Compared to other planets, it feels reachable. We know we can send machines there, and we are planning to send humans. The idea of discovering ruins on a world that people might one day walk across makes the speculation feel real. Unlike distant exoplanets, Mars is within our grasp. That closeness makes it easy to imagine archaeologists of the future digging into Martian soil and finding something that rewrites history. Think also about timing. Earth is about 4.5 billion years old. Life here has taken billions of years to reach the stage of human civilization. But the universe is far older and planets form at different times. There is no law that says Earth had to be first. Mars could have cooled sooner, developed water sooner, and possibly hosted life earlier than Earth, if intelligence rose there millions of years before us. Then we may only now be arriving late to a story that already had its first act. That possibility alone keeps the question alive. In this way, Mars becomes more than just a planet. It is a mirror. When we look at it, we see not only red deserts and silent craters, but also our own reflection, our own fears of collapse, and our hopes of continuity. The idea that civilizations could come and go, even on nearby worlds, forces us to think about the fragility of our place. That is why theories of lost Martian civilizations continue to capture attention, even when science offers no proof. It is not only about what Mars was, but about what we are willing to believe is possible. When we think about life, we almost always begin with water. On Earth, every living organism depends on it. The oceans, lakes, and rivers are the starting point for biology. Even in the driest deserts, where life hangs on by a thread, small traces of water sustain it. So when scientists turn their eyes toward other planets, water becomes the first question. If you can find it, you can argue for the possibility of life. And Mars, for all its dry and dusty appearance today, carries strong evidence that it once had plenty of it. The first real clues came from orbit. Spacecraft sent to circle Mars returned images that didn't just show craters and dunes. They revealed valleys carved into the surface that looked remarkably like riverbeds. Some of them stretched for hundreds of kilometers, winding in the same patterns as rivers on Earth. Others fanned out into delta-like shapes, the way rivers spread sediment when they meet lakes or seas. These features are difficult to explain without flowing water. Wind can carve some patterns, and lava can create channels. But the sheer number and variety of these formations pointed to rivers. Over time, missions like Viking, Mars Global Surveyor, and Mars Reconnaissance Orbiter added more detail. They showed not just channels, but layered rocks that resemble sedimentary deposits. On Earth, such layers form when water lays down materials over long stretches of time. Some even contain minerals like clays and sulfates, which require water to form. That was the turning point. This wasn't just a planet with a few strange features. This was a planet that had, in its past, widespread liquid water across its surface. Then came the rovers. Spirit, Opportunity, Curiosity, and Perseverance landed on Mars at different sites and provided ground-level confirmation. Spirit found evidence of volcanic rocks that had been altered by water. Opportunity rolled into a crater and found hematite spheres tiny, round stones nicknamed blueberries that only form in watery environments. Curiosity explored Gale Crater and discovered ancient lake beds, complete with evidence that the water there was stable and long-lasting. Perseverance, the most advanced rover so far, is exploring Jezero Crater, where a massive river delta once flowed. These findings show that Mars was not just wet for a brief moment. It held stable bodies of water for long enough that complex chemistry could take place. The picture that emerges is of a planet with a very different past. Billions of years ago, Mars likely had a thicker atmosphere. That atmosphere trapped heat and allowed water to remain liquid on the surface. Oceans may have covered large parts of the northern hemisphere. Rivers cut through the land, feeding lakes that lasted for thousands or even millions of years. Ice caps at the poles grew and shrank with the seasons, just as they do now, but with far more liquid water flowing from them. For long stretches of time, Mars may have been as blue and wet as Earth. This changes the way we think about habitability. Life does not emerge instantly. On Earth, the first microbial life appeared fairly quickly after the planet cooled enough for liquid water, but it took billions of years for complexity to evolve. If Mars had stable water for millions of years, that is enough time for something more than microbes to emerge. The chemistry required for life, carbon, water, and energy sources was likely all present. volcanoes provided heat and minerals. Sunlight reached the surface through a protective atmosphere. The ingredients were there. Now the question shifts from whether water existed to what it means. Could Mars have developed simple life? Many scientists believe it is very possible. Microbes thrive in extreme environments on Earth, deep underground, in acidic pools, even inside Antarctic ice. If life can survive here, it could have survived on Mars when conditions were better. Some even argue that life could still exist today, locked away under the surface where ice melts into occasional pockets of water. But when you bring up the idea of civilization, the conversation becomes more speculative. Could water on Mars have supported not just microbes, but something more advanced? The cautious answer is that we have no direct evidence. Still, it is not impossible to imagine. On Earth, once stable water systems existed, ecosystems emerged. Fish, plants, and eventually complex animals developed. Intelligence is harder to achieve, but water is the foundation that allows it. If Mars held oceans for millions of years, then it is not absurd to ask whether it could have also supported organisms capable of more than survival. One interesting piece of speculation comes from the timing. Mars and Earth formed around the same time, but Mars is smaller and may have cooled faster. That means liquid water could have existed there earlier than it did on Earth. If life began first on Mars, then intelligence could have had a head start. While Earth was still chaotic, hammered by impacts and unstable climates, Mars might already have had stable oceans and time for biology to unfold. This opens the door to the idea that life, perhaps even advanced life, might have existed there long before Earth developed its own. There are also smaller, stranger hints that feed the speculation. For example, some meteorites found on Earth have been identified as originating from Mars. These rocks were blasted off the Martian surface by impacts and drifted through space until landing here. A few of them contain structures that some scientists interpret as possible microfossils. While this is debated and not widely accepted, it raises the possibility that Mars not only had water, but may have developed microscopic life forms. If that much is possible, then the question of what else might have existed becomes more compelling. Water also connects to the idea of civilization in another way: infrastructure. On Earth, every advanced culture has depended on controlling water. From irrigation in Mesopotamia to aqueducts in Rome, water management is at the center of human development. If an intelligent species had existed on Mars, it would almost certainly have left behind traces of water systems. Canals, reservoirs, or modified riverbeds would be logical signs. Interestingly, these are the exact features early astronomers thought they saw when they described Martian canals, while modern science attributes those lines to optical illusions. The coincidence is striking. If you wanted to imagine evidence of Martian civilization, water systems would be the place to look. But here is where we hit a wall. While we see clear evidence of natural water systems, we do not yet have proof of artificial ones. The rivers and deltas appear natural, shaped by geological processes rather than intelligent design. Still, the fact that they exist keeps the question open. Civilization needs a foundation, and Mars appears to have had the raw material for one. There's also the question of where all that water went. Today, Mars is dry and cold, with only ice at the poles and underground. Much of its atmosphere was lost to space, stripped away by solar winds once its magnetic field weakened. Without that shield, the planet could no longer hold on to heat or water. Oceans evaporated, rivers dried up, and Mars became the desert we see now. If a civilization had existed, this change would have been catastrophic. Entire ways of life would have collapsed as the climate shifted beyond what was survivable. This is another reason the theory of a lost Martian civilization persists. The planet clearly underwent a massive transformation, one that could have wiped out life if it had ever flourished there in the end. The evidence of ancient water systems doesn't give us definitive answers, but it sets the stage. It tells us Mars was once a place of rivers, lakes, and possibly oceans. It tells us the environment was stable enough to sustain complex chemistry, perhaps even biology. And it tells us the planet changed dramatically, losing its water and atmosphere over time. Too many. This is enough to imagine that life may have taken root and perhaps grown into forms we have not yet discovered. Every new mission aims to get closer to this question. Rovers drill into rocks, scoop up soil, and analyze samples for signs of organic compounds. Orbiters map hidden ice deposits and search for underground reservoirs. Future missions may even return samples to Earth for closer study. If we find evidence that microbes once lived in those ancient waters, it will be one of the most important discoveries in human history. And if we ever find hints of something more, something resembling intelligence, it will completely reshape our understanding of both Mars and ourselves. For now, the story remains unfinished. We know water was there. We know it shaped the land. What we do not yet know is what lived beside it. That unanswered question is what keeps the possibility of ancient Martian civilizations alive in our imagination. When we look at Mars today, one of the first things scientists notice is how thin its atmosphere is. Standing on its surface, you would feel almost nothing pressing against your skin. The air pressure is less than 1% of Earth's. The sky looks hazy and red, not blue. Without a spacesuit, you would not be able to breathe. And without significant protection, your blood would begin to boil from the lack of pressure. It seems impossible to imagine this world as anything but hostile. And yet, when we study its past, the evidence points to a very different picture. A planet with a thick, protective atmosphere. One capable of supporting water and maybe even life. The thinness of Mars' present atmosphere is part of what makes it look dead. It cannot trap much heat, so the planet is cold, with average temperatures far below freezing. It cannot block solar radiation effectively, so the surface is exposed to damaging cosmic rays and solar winds. And it cannot hold large amounts of water vapor, so most water escapes into space or is locked away as ice. But billions of years ago, the situation was likely the opposite. We know that the early solar system was chaotic. Planets were bombarded by asteroids, their surfaces molten and unstable. Over time, things cooled. On Earth, volcanic eruptions and outgassing released water vapor. Carbon dioxide, methane, and nitrogen into the sky, building up a dense atmosphere. Something very similar must have happened on Mars. Its volcanoes, the largest in the solar system, like Olympus Mons, were enormous. They spewed out gases that would have filled the sky. The result was a much thicker atmosphere than what we see today. Evidence for this comes from multiple sources. One is the landscape itself. Ancient river valleys, deltas, and lakes would not have been possible if water evaporated instantly into space. They required a protective blanket of air above them, strong enough to maintain stable liquid water. That means Mars once had air pressure far greater than today. Another clue lies in the chemistry of rocks and minerals. Certain minerals form only in the presence of carbon dioxide and water under stable atmospheric conditions. Scientists studying Martian rocks through rovers and orbiters have found such minerals, suggesting that carbon dioxide levels in the past were much higher. This fits with the idea of a greenhouse effect on ancient Mars. A warm, thick atmosphere, trapping enough heat to keep water flowing across the land. There is also the evidence of erosion. Some craters on Mars appear worn down, as if softened by wind and rain. This would require both water and weather, things that can only exist with a denser atmosphere. The erosion patterns hint at a planet that once had clouds, storms, and cycles much like Earth's, though on a different scale. The atmosphere is more than just air. It is also a shield. On Earth, our atmosphere protects us from harmful radiation. The ozone layer filters ultraviolet light while the magnetic field deflects solar wind. Mars at one point must have had something similar. We know this because without such protection, life could never have stood a chance. Radiation would have destroyed organic molecules before they could assemble into anything meaningful. But the minerals on Mars suggest complex chemistry once took place, and that chemistry needed shelter. So, what happened? Why did Mars lose this protective atmosphere? The leading theory is that its smaller size played a role. Compared to Earth, Mars is about half the diameter and has less mass. That means its gravity is weaker, making it harder to hold on to light gases over billions of years. At the same time, Mars' core cooled faster than Earth's. Once the molten core cooled, the planet lost its global magnetic field. Without that magnetic shield, the solar wind stripped away the atmosphere. Bit by bit, the gases were blown into space, and the thick air thinned into almost nothing. NASA's MAVEN mission has confirmed this process by directly measuring how the solar wind interacts with Mars today. Even now, the planet loses small amounts of its atmosphere every second. Extrapolating backward, scientists believe that billions of years ago, the loss was much greater. What we see today is the final stage of a long decline. This loss of atmosphere is critical to understanding habitability. With a thick atmosphere, Mars would have had temperatures above freezing, stable liquid water, and protection from radiation. These are the same conditions that allowed life to flourish on Earth. Without the atmosphere, everything collapsed. But during the time when Mars still had it, the planet may have been a cradle for biology. Think about what that would have looked like. The sky might not have been red, but blue or gray, filled with clouds. Rain could have fallen, shaping valleys and feeding lakes. Winds would have moved dust across the land, just as they do today, but with more force, shaping dunes and carrying moisture. Rivers would have flowed steadily, perhaps even forming an ocean in the northern plains. It is not hard to imagine this as a living planet, even if only at the microbial level. Some researchers suggest that early Mars could have supported not just survival, but thriving ecosystems. If lakes and rivers persisted for millions of years, organisms would have had time to evolve. Microbes could have colonized soils, forming mats or biofilms like the ones we see in Earth's shallow waters. Algae-like organisms might have grown in lakes, feeding off sunlight and carbon dioxide. If evolution had enough time, perhaps more complex life could have emerged. On Earth, all it took was the right balance of water, atmosphere, and energy. Mars may have had all three. The atmosphere also raises a speculative but important question. Could an intelligent civilization have depended on it? If Mars once had an environment similar to early Earth, then it provided the same basic foundation. For intelligence to rise, you need long-term stability. A thick atmosphere could have provided just that. If civilizations require hundreds of thousands or millions of years to develop, Mars might have had the window of opportunity. This is where imagination stretches beyond the limits of current science. No one has found ruins, tools, or direct evidence of Martian intelligence. But the atmosphere provides the stage on which such a story could have played out. If beings lived on Mars, they would have looked to the skies, breathed its air, and built their survival on rivers and lakes. They might have even noticed, as the air thinned over generations, that something was changing. For them, the collapse of the atmosphere would have been a slow-motion disaster. 1-2, gradual to stop. When we compare Earth and Mars, we see a cautionary tale. Earth has kept its atmosphere thanks to its stronger gravity and magnetic field. Mars lost both, and in losing them, it lost its habitability. This comparison forces us to see how fragile life is. Civilizations depend not just on intelligence, but on planetary systems that can collapse if one factor changes. Even today, the story is not over. Mars still has an atmosphere, thin as it is. Seasonal changes release gases from the poles. Dust storms can warm the planet temporarily by trapping heat. traces of methane have been detected, sparking debate because methane can come from either geological or biological sources. While the atmosphere is not what it once was, it still carries mysteries. Future missions may tell us more. Scientists dream of drilling deep into the Martian crust, where evidence of the old atmosphere may be trapped. They also hope to analyze isotopes of gases more precisely, to understand exactly how fast Mars lost its air and what that meant for surface conditions. If we can reconstruct that story, we may finally know whether Mars truly had the right balance to support life and for how long. For now, the thicker atmosphere of ancient Mars remains one of the strongest arguments that the planet was once habitable. Without it, water would have frozen or evaporated instantly. With it, the surface could have been stable enough for life to take root. That single fact that Mars once had skies heavy with air keeps the possibility alive that civilizations might not be unique to Earth. The air is gone, but the memory of it is written into the rocks and valleys, waiting for us to read. When we talk about Mars today, the word that comes to mind is dryness. Dust storms, red deserts, endless dunes, and barren craters paint the image of a dead world. Yet when we trace its history backward, the picture changes dramatically. Mars once had water, not just in small amounts, but on a planetary scale. Rivers carved valleys. Lakes pooled inside craters. Vast stretches of its northern hemisphere may have been covered by a shallow ocean. And where there is water, there is always the possibility of ecosystems. The evidence for Martian oceans is compelling. Satellite images of the northern plains show what looks like an ancient shoreline, ridges and formations that stretch for thousands of kilometers, wrapping around the low-lying areas like the outline of a basin. These features resemble coastlines on Earth, where oceans meet land. Some scientists argue that these formations are too uneven to be true shorelines. But the debate continues because the patterns are difficult to dismiss. If those lines are indeed ancient beaches, then Mars once held an ocean as large as the Arctic Ocean on Earth. Beyond the possible ocean, rivers appear all across the planet. Dry channels wind across the surface, branching and joining in patterns identical to terrestrial river networks. These are not random. They follow gravity, cutting valleys that spread into deltas where they likely met lakes or seas. The best example of this is Jezero Crater, where NASA's Perseverance rover is exploring today. From orbit, it can clearly see the remains of a river delta, layered sediments that formed as water slowed down and dropped material at the crater's edge. On Earth, deltas like this are hotbeds of biodiversity. They concentrate nutrients and provide habitats for countless species. If Mars ever had life, deltas would have been among the best places for it to thrive. Lakes are also part of the picture. Craters across Mars show evidence of once being filled with water. Sedimentary layers inside them tell the story of long-standing lakes, not brief floods. Gale Crater, where the Curiosity rover has been working for years, once held a large lake that may have persisted for millions of years. The rocks inside the crater reveal mudstones and minerals that only form in calm, standing water. Imagine for a moment that this dry, dusty bowl once shimmered with blue water under a thicker Martian sky. For millions of years, such a lake could have been a stable environment for microbes, algae, or even more complex organisms to develop. The key point is duration. Short bursts of water would not be enough for ecosystems to establish themselves. But the evidence suggests that Mars had stable water systems over long spans of time. That means cycles, rainfall, rivers feeding lakes, evaporation, and perhaps even precipitation returning from clouds. If these cycles lasted millions of years, then Mars had more than just temporary habitability. It had the conditions for ecosystems that could evolve, adapt, and expand. On Earth, ecosystems flourish wherever there is water. Deep sea vents host life without sunlight. Hot springs and acidic pools sustain specialized microbes. Even Antarctic lakes sealed under ice carry living organisms. The lesson is clear. Life is incredibly adaptable when given liquid water and a source of energy. Mars, during its wet era, would have provided both. Sunlight could have driven photosynthesis in shallow lakes. Volcanic activity could have supplied minerals and heat. Chemical gradients in water could have fueled microbial metabolisms. These are the same ingredients that sustain life here. The speculation becomes even more interesting when we consider complexity. Microbes are one thing, but ecosystems require interaction. On Earth, even in small ponds, microbes give way to algae, which support tiny animals, which feed larger ones. Could Mars have supported such chains? We do not know. The fossil record here on Earth shows that once life appears, it tends to branch into niches, creating networks of dependence. If Mars had millions of years of stability, it is reasonable to imagine at least microbial mats, biofilms, or colonies forming ecosystems of their own. If we stretch our imagination further, we might ask, could Mars have gone beyond microbes? The cautious answer is that there is no evidence yet. But the conditions that allowed life on Earth were not unique. Earth had oceans, lakes, rivers, and stable climates. Mars, for a time, did too. That parallel makes speculation about complex ecosystems possible, even if unproven. There are also intriguing geological hints that suggest Mars may have had more dynamic water systems than we once thought. For example, deposits in certain valleys look like they were shaped by catastrophic floods, as if ice dams broke and released torrents of water across the land. Such events would have reshaped the landscape, carrying sediments and nutrients across wide areas. On Earth, floods often spark bursts of new growth afterward, redistributing resources and opening new niches. If Mars had life, floods could have played a similar role, spreading it and reshaping habitats. The idea of an ocean in the north is especially important. Oceans create global systems. They regulate climate, distribute heat, and provide enormous habitats. If Mars truly had one, even for a few 100 million years, then it would have been a planet with a full water cycle: clouds, rain, rivers, seas, and evaporation repeating endlessly. That is not a static desert. That is a living system, the kind of stage where ecosystems can rise and fall. Some scientists even propose that if Mars had an ocean, could have influenced its geology in ways we have not fully recognized. On Earth, oceans contribute to plate tectonics, erosion, and sedimentary layering. While Mars does not show clear signs of plate tectonics, it does show layering, erosion, and deposition on a large scale. This reinforces the idea that water shaped its surface profoundly, in ways only possible with long-term presence. For those who entertain the idea of civilization, oceans and rivers add another layer. Civilizations build around water. On Earth, the earliest cities rose along rivers like the Nile, Tigris, and Euphrates. Trade routes followed seas. Agriculture depended on rivers and lakes. If intelligent beings had ever lived on Mars, they too would have centered their lives around these water systems. The traces of rivers and deltas we see today would have been their lifelines. While we have no direct evidence of such activity, the fact that Mars had the same raw structures makes it possible to imagine. What makes the Martian story haunting is its ending. The water is gone. The lakes are dry, the rivers empty, the ocean vanished. Ice remains at the poles, and traces of briny water may seep seasonally, but the grand systems are no longer there. If ecosystems once flourished, they would have collapsed as the atmosphere thinned and the climate froze. This image of abundance followed by desolation is what keeps people fascinated. It suggests a planet that was alive, at least in potential, and then died. Modern missions aim to settle some of these questions. Perseverance is collecting samples from Jezero crater to be returned to Earth. Scientists hope those rocks may contain microfossils, or chemical signatures of past life. If they do, it will confirm that Mars, rivers, and lakes were more than empty basins. They were once homes. And if we find nothing, the mystery deepens. Did Mars really waste its chance? Or are we just not looking in the right places? There's also the chance that remnants of those ecosystems still survive underground. Even as the surface froze, subsurface aquifers may have persisted. If microbes adapted to those hidden waters, they could still be alive today, waiting for us to drill deep enough to find them. That possibility keeps the search active. Mars is not only about the past, but about whether its ecosystems ever fully vanished in the end. The rivers, lakes, and oceans of Mars are not just geological curiosities. They are markers of potential. They tell us that Mars was once a planet with the same essential conditions that allowed Earth to become alive. And that means, at least for a while, it may have hosted ecosystems of its own. Whether those ecosystems were microbial mats in shallow lakes or something more complex, the fact remains that Mars was once wet, dynamic, and full of opportunity. That knowledge reshapes how we see the planet. It is not just a desert world that failed. It is a place that might have carried life, perhaps even thriving ecosystems, before losing everything. And for us, standing on a planet still full of water, it is a reminder of how fragile that balance can be. When satellites first began mapping Mars in detail, people were not just looking for geological features. They were also searching for signs of something more, patterns or structures that looked too familiar to be explained by chance. It didn't take long before photographs from orbit started to spark debate. Among the most famous images is the so-called face on Mars, a formation in the Cydonia region that, in its first blurry photos, appeared to show the outline of a human-like face staring back into space. For many, this was the moment Mars shifted from being simply another planet to becoming a world with the possibility of a hidden past. The face on Mars was photographed by NASA's Viking 1 orbiter in 1976. At the time, image resolution was limited, and shadows across a mesa created the illusion of eyes, a nose, and a mouth. To the human brain, which is wired to recognize faces even in random patterns, the effect was powerful. Newspapers published the image, and almost immediately, speculation grew. Could this be evidence of an ancient Martian civilization that carved monuments much like humans did with pyramids and statues? Books, television shows, and documentaries spread the idea, embedding it into public imagination. Later missions, with higher resolution cameras, showed that the face was simply a hill. When lit differently, the illusion of facial features disappeared. Scientifically, the mystery was solved. Yet, for many people, the fascination did not go away. The reason is not only the image itself, but what it represents. The idea that another world might contain deliberate structures taps into something deep within us. We want to believe that we are not the only species to have shaped our environment with intention. The face on Mars was not alone in sparking these questions. In the same Cydonia region, some researchers and enthusiasts pointed to other features they believed resembled pyramids, with sharp angles and apparent symmetry. From orbit, clusters of hills sometimes align in ways that look geometric. On Earth, geometry is often a signature of design. Squares, triangles, and circles do not appear often in nature, but they are common in human construction. That resemblance was enough to ignite speculation about pyramids on Mars. Scientists argue that these are natural formations. Erosion, impact craters, and wind can create shapes that look organized from certain perspectives. But the resemblance to human-made structures is difficult for many to dismiss. Even if coincidence, the idea of pyramids on Mars persists in books, articles, and countless discussions online. People point out that civilizations on Earth, from Egypt to Mesoamerica, built pyramids as monuments or temples. If pyramids appear on Mars too, even as illusions, The connection feels meaningful, as if there is some hidden pattern linking worlds together. This phenomenon is known as pareidolia, the human tendency to see patterns in randomness. We see faces in clouds, animals in rock formations, and familiar shapes in constellations. On Mars, where the surface is vast and unfamiliar, pareidolia is inevitable. Every unusual shadow, every oddly shaped hill becomes a candidate for speculation. But pareidolia alone does not explain why the public clings so strongly to these features. The deeper reason is that Mars already feels like a place where life could have existed. Once that seed is planted, every strange image becomes potential evidence. One reason these structures attract attention is that they resemble ruins. On Earth, ruins are powerful symbols of lost civilizations. From the pyramids of Giza to the stone heads of Easter Island, they remind us that human cultures have risen and fallen, leaving behind monuments that outlast the people who built them. When we look at Mars and see shapes that mimic ruins, the association is immediate. It is easy to imagine that we are looking at the remains of a civilization erased by time. The barren deserts of Mars even amplified this feeling, since they resemble earthly deserts where ruins are often preserved. The scientific community is cautious, but even scientists acknowledge that these formations serve an important role in exploration. They remind us to keep questioning. If we too quickly dismiss unusual shapes as coincidences, we might overlook real evidence. After all, archaeology on Earth began with people noticing patterns in rocks and landscapes that turned out to be deliberate. While no credible proof exists yet that Martian structures are artificial, the debate ensures we do not ignore possibilities. What makes the story more complex is that Mars does have geology capable of producing features that mimic construction. Volcanic activity impacts and wind erosion can create sharp edges and flat surfaces. Craters can align by chance, and landslides can form geometric patterns. Yet, when we look at them through the lens of our own history, it becomes almost irresistible to assign meaning. If you were to show someone who had never seen Earth's pyramids a picture of the Egyptian desert, they might think the pyramids are just odd-shaped hills. Context is everything, and on Mars, we lack the context to know for sure, beyond the face and pyramids. Other strange formations on Mars also feed speculation. Some images show rocks that look like statues, broken machines, or even bones. Scientists explain these as erosional features shaped by wind and dust storms. But the fact that so many of them resemble familiar objects keeps the conversation alive. It becomes a cycle. We expect to see something unusual, we find it in photos, and the speculation grows. Even when debunked, the images fuel imagination. This has created a divide between mainstream science and public fascination. Scientists prefer caution, emphasizing natural explanations. The public, however, thrives on mystery. In some ways, both sides are necessary. Science demands skepticism, while curiosity drives exploration. The balance between the two ensures that we keep pushing forward, even if most of what we find turns out to be natural. The question of structures on Mars is a good example of this balance. They may be illusions, but they keep us looking more closely at the planet. And that attention could one day uncover something truly significant. If we step back, we can see why this matters for the broader story of Martian habitability. Imagine that we had never noticed the face on Mars or the so-called pyramids. Public interest in Mars exploration might have been weaker. But because these features sparked imagination, governments and space agencies were pressured to continue missions. The search for signs of life gained momentum, partly because of these controversies. In that sense, even illusions play a role in discovery. There is also a philosophical angle. If intelligent life once existed on Mars, what would we expect to find? Would they build monuments like humans, or would their traces look different? It is possible that we are looking for the wrong kinds of evidence. By projecting human patterns onto another planet, we might be narrowing our vision. Civilizations could leave behind markers that we do not even recognize as artificial. The face in pyramids remind us that interpretation is subjective. What looks like a ruin to us might be nothing more than geology. And what looks like geology might one day turn out to be a ruin in the end. The strange surface structures of Mars matter less for what they are and more for what they represent. They symbolize our desire to connect with something beyond ourselves. They keep the possibility of Martian civilizations alive, even when science leans toward natural explanations. And they illustrate how fragile the line is between evidence and imagination. For now, the face on Mars is a hill. The pyramids are natural mounds, and the statues are just rocks. But the mystery they spark ensures that the search for real answers continues. When we look at Mars today, what we see is not just a barren planet, but the aftermath of a collapse. Its valleys are dry, its atmosphere thin, and its volcanoes extinct. Something happened in its past that changed it from a world of rivers, lakes, and perhaps oceans into the cold desert we see now. To understand Mars, we have to ask not only what it once was, but also what went wrong. And this is where the idea of planetary catastrophe enters the conversation. The simplest explanation is gradual change. Mars is smaller than Earth, which means it cooled faster. Its core solidified, its magnetic field weakened, and without that magnetic shield, solar winds stripped away the atmosphere. With less atmosphere, the climate grew colder and liquid water vanished. Over time, the planet froze into stillness. That's the mainstream scientific view. But the picture may not be so simple. Many researchers suggest that Mars experienced sudden, catastrophic events that accelerated its decline. One possibility is asteroid impacts. The surface of Mars is covered with craters, some of them enormous. The largest Hellas Basin is over 2,000 kilometers wide and several kilometers deep. Impacts of this scale release unimaginable energy, enough to heat the atmosphere, melt ice, and even disrupt the entire planet's climate. If Mars had stable oceans or lakes at the time, a massive impact could have boiled them away in an instant, throwing water and atmosphere into space for any life or civilizations that might have existed. Such an event would have been devastating. There's evidence that these impacts were not rare. In the early solar system, both Earth and Mars endured heavy bombardment. On Earth, much of that record has been erased by tectonics and erosion. On Mars, where geological activity is less intense, the scars remain. Some scientists argue that repeated large impacts could explain why Mars lost so much of its atmosphere faster than Earth did. Each strike would strip away gases and destabilize the climate further, turning a once habitable planet into an unstable one. Another catastrophic possibility involves volcanism. Mars is home to Olympus Mons, the largest volcano in the solar system. Nearly 3 times the height of Mount Everest and as wide as France. It, along with other giant volcanoes on the Tharsis Plateau, suggests that Mars once had immense volcanic activity. Such activity could have both helped and hurt habitability. On one hand, volcanoes release gases, thickening the atmosphere. On the other hand, supereruptions can change climates dramatically, releasing toxic gases and blocking sunlight with ash. Some researchers suggest that a period of intense volcanism may have temporarily warmed Mars, creating habitable conditions, before eventually contributing to long-term instability. Then there's the possibility of climate collapse driven by atmospheric chemistry. If Mars had a thick carbon dioxide atmosphere, as most scientists believe, it could have supported liquid water. But without a strong magnetic field, solar radiation would have gradually stripped it away. At some tipping point, the balance may have broken suddenly. Once pressure dropped below a certain threshold, water would have boiled away, creating a runaway effect. Oceans and rivers could have vanished in geologically short timescales, not millions of years, but perhaps thousands. To any life that depended on them, this would have felt like a catastrophe. Speculative theories go even further. Some researchers and independent thinkers have proposed that Mars may have suffered events resembling nuclear-scale devastation. Unusual isotopes detected in the atmosphere, such as xenon-129, have been cited by a few as possible evidence of past nuclear explosions. The mainstream view is that these isotopes are the result of natural cosmic radiation and planetary processes. But the idea of ancient nuclear catastrophe lingers in popular imagination. If true, it would mean Mars once had forces of destruction far beyond natural climate collapse. Whether we think in terms of impacts, volcanism, or atmospheric loss, the theme is the same. Something dramatic erased Mars' habitability. And the possibility that civilizations could have existed before such an event makes the question even more haunting. If intelligent life had developed on Mars, it would have faced a crisis larger than anything humanity has yet known. Imagine a society watching its rivers dry up, its skies thin, and its world grow colder with each passing century. Imagine the desperate attempts to adapt, moving underground, searching for ways to hold on to water, or even trying to escape the planet entirely. If such a story happened, the traces may still be buried in the dust. This is why catastrophe theories are so compelling. They explain not only why Mars is dead now, but also how it could have once been alive. Catastrophes leave behind ruins, both geological and cultural. On Earth, we see this in the fossil record: sudden extinction events, layers of ash, craters from impacts. On Mars, the ruins may not be bones or fossils, but valleys carved by sudden floods, craters from massive impacts, or chemical signatures of vanished oceans. The idea of a planetary catastrophe also resonates, because it mirrors fears about our own world. Earth is not immune to collapse. Climate change, asteroid impacts, and nuclear conflict are threats we understand. Mars becomes a cautionary tale, a world that may have once thrived but was undone by forces beyond its control. To study its catastrophes is to study our possible future. We can see hints of these catastrophes in the landscapes captured by rovers and orbiters. Dry river valleys that end abruptly, as if the water stopped overnight. Layered rocks that suggest cycles of wet and dry, broken suddenly by desolation. Giant canyons like Valles Marineris, stretching for 1,000 kilometers, which may have opened through tectonic collapse or catastrophic flooding. These are not the slow, steady marks of time, but the scars of violent change. For those who speculate about civilizations, the catastrophe narrative is particularly powerful. It provides a reason why we find no obvious ruins. If Mars underwent planet-wide destruction, much could have been erased. Cities could have been buried under kilometers of dust, eroded beyond recognition, or obliterated by impacts. Unlike Earth, which renews itself through tectonics and weather, Mars preserves its surface scars. If ruins exist, they are hidden among millions of years of catastrophe. Yet, even in catastrophe, survival is possible. Some scientists suggest that microbial life could have retreated underground as the surface became uninhabitable. There, shielded from radiation, warmed by geothermal heat, and sustained by pockets of water, they could persist even today. If so, then catastrophe did not erase everything. It simply pushed life into hiding. This raises the possibility that Mars is not only a story of loss, but of endurance. When we think about catastrophe on a planetary scale, we often picture it as sudden and dramatic. But on Mars, catastrophe may have been both sudden and slow. Impacts and eruptions could have caused instant devastation, while atmospheric loss stretched across millions of years. To any beings living there, it would have been experienced as both disasters in the moment and gradual decline over generations. A society might have had time to recognize what was happening, but not enough power to stop it. What makes this story compelling is that it remains unfinished. We do not yet know the exact timeline of Mars' decline. We do not know how quickly it lost its oceans or how sudden its catastrophes were. Each new mission adds pieces to the puzzle, but also opens new questions. Was Mars' habitability ended by a single massive event, or by the slow erosion of its defenses? Did catastrophe strike while life was flourishing, or before it had a chance to take hold? What is clear is that Mars bears the marks of a world undone. Whether the catastrophe was impact, volcanism, atmosphere loss, or something else, the result was the same: a shift from potential habitability to desolation. For us, standing on Earth, this lesson is sobering. It shows that planets are fragile, that the conditions for life can be lost, and that civilizations, if they ever existed there, can be erased without a trace. When people think about the possibility of life on Mars, they usually imagine microbes or, at most, strange ecosystems that never advance beyond a simple stage. But there is another idea that sometimes appears in both science and speculation. If Mars was once habitable and possibly home to life, could some of that life, even intelligent life, have migrated to Earth? This is not only a science fiction theme, but also a serious hypothesis considered in scientific circles, though usually in the form of microbes rather than civilizations. The theory is called panspermia, and Mars is one of the strongest candidates in our solar system for having past life to Earth. The foundation of this idea comes from planetary impacts. When asteroids or comets strike Mars, they hit with tremendous force. These collisions can blast chunks of Martian rock into space. Over time, some of those rocks drift across the solar system. A small percentage eventually land on Earth as meteorites. We have already collected dozens of such Martian meteorites, identified by their chemical signatures that match the Martian atmosphere measured by probes. This proves that pieces of Mars regularly travel to Earth. Now the question is, what might have been carried with them? If Mars had microbial life billions of years ago, it is possible that some of it could have been sealed within those rocks. Inside cracks or pores, shielded from radiation, microbes might have survived the long journey through space. When the meteorites eventually fell to Earth, they could have delivered Martian organisms into our environment. If this happened early enough in Earth's history, those organisms might have seeded life here. In other words, we may not be descendants of Earth at all. We may be the children of Mars. Scientists call this the Mars seeding hypothesis. And while it is speculative, it is not entirely far-fetched. Experiments have shown that certain microbes can survive the harsh conditions of space for surprisingly long periods, especially if protected inside rock. Radiation is a danger, but not all organisms are equally fragile. Some extremophiles on Earth can survive freezing, drying, and radiation exposure far beyond what humans could tolerate. If similar organisms ever existed on Mars, they might have endured long enough to make the journey. What makes this idea even more interesting is the timing. Earth, early in its history, was violent and unstable. Constant impacts, volcanic eruptions, and a shifting crust made it a harsh environment. Some scientists argue that conditions may have been so extreme that it was difficult for life to originate here. Mars, being smaller and possibly cooling faster, might have developed stable conditions earlier. If life began there first, it could have had a head start. And if meteorites carried it to Earth, then Earth's biosphere may have been seeded not by its own chemistry, but by imports from Mars. That version of panspermia usually stops at microbes, but the human imagination does not. If Mars had life, and if it had time to evolve into something more advanced, could intelligent beings have also attempted to migrate? This is a larger leap, but not beyond the realm of speculation. If a civilization saw its planet dying, losing its atmosphere, drying up, freezing over, it would have faced a choice. Either adapt underground, perish with the changing environment, or attempt to escape. If escape was possible, Earth would have been the most logical destination. It was nearby, larger, warmer, and rich in resources. Of course, this idea encounters serious problems. For intelligent beings to migrate, they would need technology capable of space travel. So far, we have no evidence of such technology on Mars. There are no ruins, no artifacts, no signs of machinery. But if we entertain the idea hypothetically, migration might not have been what we expect. It may not have involved rockets or spacecraft as we understand them. It could have taken forms we do not recognize: biological seeding, genetic manipulation, or even deliberate use of asteroids as transport. If an advanced species wanted to survive, it might have found ways beyond our current imagination. Even if no civilization migrated deliberately, there's still the possibility of accidental migration through natural processes. Meteorites, as we know, can carry microbes. But what if, at some point, they carried more than microbes? Could fragments of Martian ecosystems frozen within rocks have been deposited on Earth, introducing not just single cells, but entire communities of organisms? While highly unlikely, it's not impossible. Planetary science teaches us that the solar system is interconnected. Material moves between worlds, and with it, the potential for life to travel. The cultural impact of this idea is just as strong as the scientific one. If we discovered tomorrow that life on Earth came originally from Mars, it would change how we see ourselves. We would no longer be purely Earthlings. Our identity as a species would stretch across planets. Earth would still be our home, but Mars would be our birthplace. Civilizations would have risen here, but their ultimate origins would lie in a world that is now silent. That realization would reframe our history as not beginning on Earth, but continuing here after Mars had already lost its chance. There is also a philosophical side to consider. If Mars seeded Earth, then life may not be as rare as we think. It means that life can move between planets, spreading wherever conditions allow. That increases the chances that life exists elsewhere in the universe. The leap from non-living chemistry to living organisms is difficult. But if life can move once it has started, then the galaxy may be full of seeded worlds. Mars to Earth migration would be one small example of a universal process. For those who like to stretch speculation, the migration theory also raises questions about human intelligence itself. What if we are, in some distant sense, Martians? Not just biologically through microbes, but culturally through deeper ancestry we have no memory of. Could the myths of lost civilizations, of gods coming from the sky, be distorted memories of a past when beings from Mars arrived here? Mainstream science does not support this view. But it is the kind of question that arises naturally once you consider migration as a possibility. What makes the theory of Martian migration powerful is that it does not require proof of advanced civilizations. Even at the microbial level, the evidence is enough to keep it alive. The fact that Martian meteorites reach Earth is undeniable. The fact that some microbes can survive extreme conditions is proven. Whether the two facts overlap, whether microbes actually traveled and survived to seed life here, remains unproven, but it cannot be dismissed. That uncertainty is enough to keep the door open. If intelligent migration ever occurred, the traces may be hidden in our own biology. Our DNA might carry signals of origins we do not yet understand. Or the migration may have left behind artifacts buried deep beneath the Martian surface, waiting for future explorers to uncover. Either way, the idea persists because it gives us a new way to connect the two worlds. It makes Mars not just a neighbor, but a potential parent or sibling. When we think about colonizing Mars today, we imagine it as a future project, sending humans there, building habitats and adapting the planet to our needs. But the migration theory flips the story. What if Mars colonized Earth first? What if we are not preparing to be the first humans on Mars, but instead returning to a place tied to our deepest origins? That possibility, even if only symbolic, changes how we see exploration. It is not only about expanding into space, but also about reconnecting with a forgotten past. Ultimately, the idea that Martian life migrated to Earth is both scientific and imaginative. Scientifically, it provides a plausible explanation for how life began here, fitting with what we know about meteorites and extremophiles. Imaginatively, it opens a window into deeper questions about identity, ancestry, and survival. Whether microbes or civilizations, whether deliberate or accidental. The possibility that life traveled from Mars to Earth reminds us that planets are not isolated. They share material, they share histories, and perhaps, in rare cases, they share life. When scientists talk about the possibility of life on Mars, the discussion often turns toward meteorites. These rocks, blasted from Mars by powerful impacts, have traveled across space and eventually landed on Earth. They are tangible pieces of another world that we can hold in our hands, study in laboratories, and test for signs of life. More than speculation, they provide direct evidence of material exchange between planets. And within this exchange lies a fascinating possibility that meteorites could have carried microbes from Mars to Earth, or even from Earth to Mars, linking the fates of the two planets in ways we are only beginning to understand. The story begins with impacts. Mars, like all planets, has been struck countless times by asteroids and comets. When a large enough object hits the surface, the energy released is immense enough to throw debris into space. Some of this debris escapes Mars' gravity entirely, drifting into orbits around the Sun. Over millions of years, some of those rocks cross paths with Earth. A fraction of them fall through our atmosphere and land as meteorites. Today, scientists have identified around 300 meteorites on Earth that are confirmed to have come from Mars. We know their origin because their chemical composition, particularly the gases trapped inside them, matches the Martian atmosphere as measured by landers and orbiters. The idea that rocks can move between planets is not just theory. It is a proven fact. And this naturally raises the question, what might those rocks have carried with them? If Mars had microbial life in the past, could any of it have survived the violent launch, the long journey through space, and the fiery descent into Earth's atmosphere? At first glance, it seems unlikely. Impacts are destructive, space is harsh, and entry through the atmosphere generates extreme heat. But research has shown that it is not impossible. Experiments with microbes on Earth have revealed surprising resilience. Certain bacteria and spores can survive vacuum, radiation, freezing, and high levels of heat. When shielded inside rock, they can endure even longer. Tests conducted on the International Space Station, for example, have shown that some microbes remain viable after years of exposure to space, especially when protected by layers of material. This resilience suggests that microbes sealed inside Martian rocks could, at least in theory, survive the journey to Earth. One of the most famous Martian meteorites is called ALH 84001. Discovered in Antarctica in 1984, scientists studying it in the 1990s announced that it contained structures resembling microscopic fossils. These shapes look like tiny worm-like forms, which some interpreted as evidence of ancient Martian microbes. The claim made headlines worldwide, suggesting that life on Mars had been discovered. Later research questioned the finding, arguing that the structures could have formed through non-biological processes. The debate continues. But ALH 84001 remains a key example of how meteorites blur the line between geology and biology. Even if the fossils are not real, the rock itself proves that Martian material reaches Earth and can preserve complex features for billions of years. Other Martian meteorites also contain intriguing clues. Some have organic molecules, carbon-based compounds that are the building blocks of life. These molecules are not proof of biology, since they can form through chemical reactions without life. But their presence suggests that the raw ingredients for life existed on Mars, and that meteorites can preserve them. If microbes ever lived there, it is not impossible that fragments of them could be carried across space in the same way. This brings us to the concept of lithopanspermia, the idea that life can spread between planets by hitchhiking on rocks. Mars and Earth are especially good candidates for this exchange because they are relatively close to each other. Impacts on either planet could send rocks flying into space, and their orbits could cross. Over billions of years, countless opportunities have existed for material transfer. If life arose first on Mars, it could have spread to Earth. If it arose first on Earth, it could have traveled to Mars. In this way, the two planets might not be separate in their biological histories, but deeply connected. The possibility of microbes traveling on meteorites is not just theoretical. Scientists have modeled the physics of impacts and found that small fragments of rock can be ejected gently, enough to avoid sterilizing heat. Once in space, they can remain stable for millions of years, drifting until gravity pulls them into Earth's atmosphere. Upon entry, the outer layers may burn, but the interior can remain cool, protecting whatever is inside. This means that microbes sealed deep within could survive the landing. In fact, meteorites that land in Antarctica or deserts are often found with their interiors pristine, untouched by contamination. The implications are profound. If even one viable microbe made the journey and found Earth's environment suitable, it could have multiplied and become the ancestor of all life here. This means that life on Earth might not have originated independently. Instead, it might be Martian in origin. We could be, in the deepest biological sense, Martians who simply evolved on a new planet. That possibility changes the way we think about our own identity. It also expands the meaning of habitability. If life can move between worlds, then once it begins anywhere, it has the chance to spread far and wide. Of course, the question remains, has this really happened, or is it only a possibility? For now, we do not know. The meteorites we have studied contain hints, but no definitive proof of living microbes. It is also possible that life originated independently on both Earth and Mars, or that neither seeded the other. Still, the fact that the transfer mechanism exists keeps the hypothesis alive. We know rocks move. We know microbes can survive extreme conditions. We know organic molecules are present. What we lack is the smoking gun, a living Martian organism, or a fossil that cannot be explained by geology alone. Future missions may provide answers. NASA's Perseverance rover is collecting samples that will eventually be returned to Earth. These samples may contain organic compounds or even microfossils preserved in sediments. If we find signs of past life on Mars, the next step will be to compare its chemistry and genetics to life on Earth. If they are similar, it will suggest a shared origin, possibly through meteorite transfer. If they are different, it will mean life arose independently on both planets, a discovery just as profound, proving that life is not unique to one world. The study of Martian meteorites also forces us to reconsider what it means for planets to be isolated. We often imagine each world as a separate experiment in life. But the truth is that the solar system is interconnected. Impacts scatter material across space, mixing the ingredients of planets together. If life exists elsewhere in our system, it may not be confined to one place. It may have spread, hidden, and adapted in ways we have not yet seen. Mars to Earth transfer is only one possibility among many. For those interested in ancient civilizations, meteorites add another layer of intrigue. If intelligent beings had ever lived on Mars, their traces could also have been blasted into space during catastrophic impacts. Artifacts or remnants might be buried within meteorites, waiting to be found. This is highly speculative, but it illustrates how meteorites become symbols of connection. They are the physical evidence that planets exchange not just rocks, but perhaps histories, even without proof of microbes. Martian meteorites tell us something important. Life, if it begins anywhere, does not have to stay there. planets are not isolated. They share material, and with it, the potential for biology to move. This makes the universe feel less like a series of disconnected experiments and more like a network, where success in one place can seed opportunities in another. In the end, meteorites from Mars suggest both possibility and humility. They remind us that Earth's story may not be entirely its own. They open the door to the idea that our origins may be shared with a world that is now silent. And they challenge us to keep looking, because within these rocks may lie answers not only to the question of Martian life, but to the deeper question of where life itself begins. For decades, our view of Mars has been limited to what machines can send us. Orbiters take sweeping photographs from above, and rovers crawl across small patches of terrain, drilling, sampling, and analyzing. These machines have given us remarkable insights: river valleys, mineral deposits, the chemistry of ancient lake beds. But they also reveal how much remains unanswered. No matter how advanced our robots become, there is a limit to what they can notice and interpret. They move slowly, cover very little ground, and are restricted to instruments we design on Earth. If there are subtle traces of past civilizations on Mars, robots might miss them. That is why many scientists and thinkers believe that the true breakthrough will come only when humans finally set foot on Mars. The difference between robotic and human. Exploration is clear when we look at history. On Earth, many great discoveries were made not by machines, but by people noticing details that at first seemed insignificant. Archaeologists walking through deserts spotted patterns of stone that turned out to be ancient walls. Explorers digging in jungles uncovered forgotten temples. These discoveries often came not from instruments, but from human intuition. The ability to see meaning in patterns, to recognize the unusual, and to follow curiosity in ways machines cannot. If there are traces of a lost Martian civilization, the first real chance to identify them may come. When human eyes and hands are on the surface, human exploration will also bring scale. Rovers like Perseverance explore a few dozen kilometers in their entire mission. A single human team could cover that much ground in weeks. They could climb hills, enter caves, and dig where machines cannot. They could bring diverse instruments, adapt experiments on the spot, and make decisions in real time. The flexibility of human exploration multiplies the chances of finding subtle evidence. Whether it be unusual stone alignments, artificial-looking structures, or chemical anomalies that hint at past biology or culture. Another advantage is the ability to return samples more effectively. Current plans involve robotic missions to collect and return small amounts of Martian rock to Earth, but humans could gather hundreds of kilograms, selecting not only what looks geologically interesting, but also what appears culturally suspicious stones that look carved, fragments that seem out of place, or deposits that resemble ruins. On Earth, many major archaeological discoveries began with fragments that looked ordinary until studied carefully. Having humans choose samples increases the odds of finding something extraordinary when we think about what human explorers might find. The possibilities fall into two categories. The first is biological traces, fossils, microfossils, or chemical markers that prove life once existed. Even this would be groundbreaking, proving that Mars was not always sterile. The second, more speculative category is cultural traces, artifacts, ruins, or evidence of structures made deliberately. These might not look like buildings or tools as we know them. Time and erosion could distort them beyond recognition. But patterns, alignments, or residues might hint at intelligent design. A trained human team, aware of these possibilities, would be far more capable of noticing them than a rover programmed only to study geology. Of course, skeptics argued that if civilizations ever existed on Mars, the evidence would be long gone. Billions of years of erosion, impacts, and dust storms would erase most traces. But history on Earth shows that not everything disappears. Stone tools survive millions of years. Fossils endure under the right conditions. Even fragile artifacts can be preserved in caves, ice, or buried sediments. On Mars, where erosion is slower than on Earth, it is possible that traces might still remain, buried under layers of dust or preserved in subsurface environments. Human explorers could drill deeper, dig wider, and explore hidden areas where machines are unlikely to go. One of the most intriguing possibilities is caves and lava tubes. Mars' volcanic past left behind vast underground channels formed by flowing lava. These tubes could be large enough to house entire cities on Earth, and they remain shielded from radiation and erosion. If life or civilizations ever retreated underground as Mars' atmosphere collapsed, these tubes would be the best places to look. Rovers struggle to explore caves, but humans, with proper equipment, could enter them. What they might find there, from microbial colonies to strange artifacts, could rewrite the story of Mars entirely. The psychological effect of human exploration should not be underestimated either. When astronauts walk on Mars, their discoveries will be experienced in real time by billions of people on Earth. A single photograph, a single announcement could capture global imagination in ways that robotic missions rarely do. If a human explorer were to hold up a rock and say, "This looks like a fossil," the impact would be enormous. Even before laboratory confirmation, the symbolic power of such a moment would shift how humanity thinks about committing Mars forever. There is also the possibility that human settlement itself will lead to unexpected discoveries. As people build bases, dig foundations, and extract resources, they will interact with the Martian environment more deeply than any robot could. Accidental discoveries are inevitable, just as construction projects on Earth sometimes uncover ancient ruins. Future Martian settlers may stumble upon evidence buried beneath the soil. These discoveries might not come from deliberate search, but from the ordinary activities of survival. The timeline for human exploration is uncertain, but increasingly discussed. NASA, SpaceX, and other organizations plan to send humans to Mars within the coming decades. The challenges are immense distance, radiation, life support, but the momentum is building. When it happens, humanity's relationship with Mars will change from distant observation to direct presence. At that moment, the possibility of uncovering traces of ancient civilization will no longer be speculation alone. It will become a practical question of what explorers find as they move across the surface. The possibility of discovering ancient civilizations on Mars is not only about curiosity, it also shapes how we see ourselves. If evidence were found, it would prove that intelligence is not unique to Earth. It would show that civilizations can rise, fall, and vanish, even within our solar system. That realization would change how we think about our own future. If Mars once had civilizations that collapsed, it forces us to consider whether Earth's future is more fragile than we imagine, even if no evidence is ever found. The act of searching has value. Human exploration will provide answers to questions that have lingered for centuries. Was Mars ever alive? Did it have oceans and ecosystems? Did intelligence ever emerge there? These answers, whether yes or no, will deepen our understanding of the universe and our place within it. They will also ground speculation in data, turning imagination into knowledge. In many ways, the idea that humans will uncover traces of ancient Martian civilizations is less about probability and more about hope. We hope to find that we are not alone, that the story of life is broader than Earth. We hope to connect with a history older and stranger than our own. And we hope that by uncovering Mars' past, we will better understand our future. Speculating about civilizations on Mars is fascinating on its own. But the deeper question is what such a discovery would mean for us. If one day we confirmed that Mars had once been alive with people or beings, whether similar to us or entirely different, the impact would ripple across every part of human life. It would not simply be a scientific breakthrough. It would be a shift in identity, philosophy, religion, politics, and our understanding of the universe itself. The first impact would be on our sense of uniqueness. For centuries, humans believed Earth was the center of the universe. Then we learned it was only one planet orbiting one star among billions. Yet, even as our place in the cosmos shrank, we held on to the idea that life, and especially intelligent life, might be unique to Earth. If Mars had once been alive with civilizations, that illusion would shatter. Intelligence would no longer be a miracle confined to one world. It would be a process, a phenomenon that can appear wherever conditions allow. The human story would instantly become part of a larger, cosmic pattern. Religions and philosophies would also face profound questions. Many spiritual traditions teach that humanity holds a special place in creation. Evidence of beings on Mars, even if long gone, would force reinterpretations. Were those beings also part of divine creation? Did they have their own spiritual paths, their own sense of morality, their own understanding of the universe? Philosophers would debate whether intelligence has inherent meaning or whether it simply emerges naturally, like rivers forming in lowlands. For some, the discovery would be unsettling. For others, it would expand the idea of creation to include multiple worlds and multiple peoples. Science, of course, would be transformed. A civilization on Mars would mean that life did not just happen once. It happened twice in the same solar system. That fact alone would revolutionize biology. It would suggest that the universe is full of life, not rare and exceptional, but common and inevitable. Every star system might carry its own stories of civilizations rising and falling. For astrobiologists, this would be confirmation that their search is not about rare miracles, but about understanding a widespread process. It would mean that we are on the verge of finding life not just nearby, but everywhere. But beyond science, there would be psychological consequences. Humanity would have to grapple with the idea that we are not the first, not even in our own cosmic neighborhood. Mars would remind us that civilizations can come before us and also vanish. That realization is both humbling and frightening. It suggests that intelligence does not guarantee permanence. Civilizations are fragile, vulnerable to planetary changes, cosmic impacts, and even self-destruction. If beings once walked Mars, looked at their sky, and built their lives, and now they are gone, then we too must face the possibility of imperial and CE. At the same time, it would create a sense of kinship. If Mars once had civilizations, we are not alone in our struggles. Others have lived, built, and perhaps perished before us. Their story, even if we can only glimpse fragments of it, becomes part of our own. Humans might look at Mars not as an alien world, but as an ancestral one, a place that carries part of our larger family history. We might even begin to see ourselves as inheritors of a legacy that spans more than one planet. The discovery would also reshape how we view exploration. For centuries, exploration has been about expanding frontiers, new lands, new oceans, new planets. But if Mars carried civilizations, exploration becomes more like archaeology. We would not only be stepping onto a new world, but into the ruins of an old one. Our missions would carry the weight of respect, curiosity, and responsibility. Every dig, every excavation, would be treated not just as science, but as a cultural encounter with beings who once lived and perhaps thought in ways we cannot imagine. Geopolitics would change too. If Mars held evidence of civilization, questions of ownership and stewardship would arise. Who controls the ruins of an ancient world? Do they belong to all humanity, to no one, or to whoever finds them first? History shows us that the discovery of ancient sites on Earth often leads to conflict over artifacts and heritage. On Mars, this would play out on a planetary scale. International laws might need to evolve to protect not only Martian environments, but also Martian history. Perhaps the most profound impact would be on the human imagination. Stories, myths, and art would be reborn with new inspiration. Children would grow up knowing that humanity was not the first intelligent presence in the solar system. Writers, filmmakers, and philosophers would explore what those civilizations were like, how they lived, and why they disappeared. The Martians, whoever they were, would become part of our shared cultural vocabulary, not as invaders from fiction, but as real beings, whose traces we uncovered in the dust. The discovery would also change our future vision. Today, we look to Mars as a place to colonize, a world to terraform, a new home for humanity. If civilizations once existed there, that vision would shift. Colonization would become continuation. Our presence on Mars would not be about creating something entirely new, but about adding to a story already begun. We would be settlers, but also archaeologists and custodians of another species' legacy. That awareness would deepen the meaning of our journey. There is another, quieter consequence to imagine. If Mars had civilizations that vanished, their absence would serve as a warning. Something ended their story. It might have been planetary catastrophe, environmental collapse, or self-inflicted destruction. Whatever the cause, their fate would be a mirror for us. Mars would not only tell us that life is common, but also that extinction is possible, even for intelligent beings. It would push us to think more carefully about our own survival, to protect our atmosphere, our ecosystems, and our fragile balance. Mars would be both inspiration and caution. And yet, the possibility of Martian civilizations also opens a hopeful door. If life existed twice in one solar system, then the universe is likely full of it. That means the chances of us being alone are slim. Somewhere out there, other civilizations may be thriving right now. We may never meet them, but knowing they exist changes everything. It transforms the universe from empty space into a living, interconnected web of stories. Mars would be our first proof that we are part of a larger family, not isolated, but connected. What would it mean to finally uncover proof of this? Imagine a human explorer brushing dust from a carved stone or holding up an artifact unmistakably shaped by intelligent hands. Imagine confirming that Mars once had people or beings with their own cultures and dreams. The moment would be unlike anything in human history. More than landing on the moon, more than discovering new continents. It would mark the day humanity learned it was not the first, not the only, and not the last. It would be the day we became part of a larger story. Even if we never find such proof, the question itself is transformative. Asking whether Mars had civilizations forces us to think differently about life, survival, and the universe. It stretches our imagination, sharpens our science, and deepens our humility. In that sense, Mars has already given us something valuable, even without clear answers. It has reminded us that the universe is bigger than our assumptions, and that the possibility of other histories makes our own even more precious. So what would it mean if Mars was once alive with beings before us? It would mean that Earth is not an exception, but part of a pattern. It would mean that intelligence is not a fragile miracle, but a recurring outcome of evolution. It would mean that we, the humans of Earth, are not writing the first chapter of civilization in this solar system, but continuing a story that began long before we opened our eyes. And perhaps, one day we will learn how that earlier story ended and how ours might be shaped by its lessons.